Hello everybody. What I want to do today is just briefly introduce bivariant data. So you might be asking yourself, why are we doing this? What is it that we need to do? And what does an exam look like? So I'm here in our OneNote document and I'm looking at this high achieved example. So the biggest thing we want to do with a graph or statistics is we want to be able to be useful. We want to make a prediction about the future. Is it any good to do this? Will this have an effect? What's going on between these two things? So in our particular example here, our person is investigating height and weight. Now, because height is on the x-axis, they're trying to use a person's height to predict their weight. Now, why is this useful? Obviously, there are health reasons involved here. If you are overweight as a relationship to your height, there is usually some impact on your health. So there's a useful reason for it. So people are reluctant to stand on a pair of scales, but they don't mind you measuring their height. So we can do a very quick measurement and tell something about this person. So they have chosen to investigate a person's height and their weight. They've got this particular bunch of numbers from somewhere and they've plugged it into a graphing program, maybe NZ Grapher, maybe Insight, but something that will produce a nice scatter graph. And this is the scatter graph they've got. Once they've got all those little dots on the page, then our next step is to fit a trend line. We want to see if there is a relationship going up. Is there a relationship going down? Is there a positive relationship? Is there a negative relationship? So the trend here is a positive relationship. The taller somebody is, the more they weigh. This is common sense, and it's nice to see sometimes the common sense comes through. So in our introduction there, we've laid out what we're going to investigate. We've said where the data comes from, and we've gone off and done a graph. Now it's time to talk about what we see in our graph. So we can see a strong relationship. There's a particular measure called R, and it's at 78%. So that's a strong relationship. They're talking about the taller somebody is, the more muscle or fat you have, it's going to make you weigh more. And then they give you an example. Somebody who's 200 centimeters tall should be around this particular weight. We can even use our model to make a prediction. So we've got this numbers here, 1.1171x minus 126. So we take their height, times it by 1.1, and then take away 26 to give us our weight. So they've taken the person's height, 190 centimeters, gone through the formula and predict that their weight should be 86 kilograms. So we carry on looking at some things. We might want to investigate another related one, height versus BMI. Now, athletes, of course, are generally quite fit, but not always. A wrestler and a weightlifter will have a totally different BMI than a gymnast. So we might want to investigate a second graph just to give us any extra information. And finally, at the end, we have to make a conclusion. Yes, there is a relationship. I'm sure of that because of this and this. I can use this to go on here. Those people who are doing excellence are moving into a place where they start to argue why their graph is no good. My graph is no good because it's only talking about people who are athletes and only talking about people who attended the Olympics. Okay? So that's where this particular data set came from. So this is useless for talking about an average, everyday person and somebody who's not an athlete. So yes, it is a relationship, but it's only for this particular group of athletes at this particular time. So that overall is bivariant.